Our first lightning talk today is going to be by Domagoj, who works at Synergize at an Earth observation research team. And he's going to speak to us about I/O operations on AWS. Yeah.
So we will have a fast talk about fast performance input-output operations on AWS. This is a lightning talk, so I tried to keep the scope small of the presentation, even if it kind of blow up in my hands. So I hope it will be clear. So why should I care about reading and writing stuff on devices? What is tricky on AWS? How to properly benchmark those operations? And at the end, we will see a use case that is training a deep learning model. This, if those 4 points would make it, then this presentation will be a success. So why should I care? Because as we know, data, the main point is that data has mass, so it's difficult to move it. And it's very difficult to move it if you are on some slow device, for example, a spinning hard drive, or it's a little bit less difficult if you have an SSD. For sure, RAM, as we know, is faster. And so the point is, since the differences are in order of magnitude, we really need to pay attention where our data resides. And depending on our application, we need to choose the right place where to store them. There are two main metrics that we should check. One is the throughput, so how much stuff I can move in a given amount of time. And operations per second, input-output operations per second, is how fast I can start reading and writing data. Oh, sorry. So when should I care about this? Well, for sure, if my data doesn't fit in RAM, then it means that I need to read them from disk. If my program, because of that, is slow, and most importantly, if I'm sure that my program is slow because I have an input-output bottleneck. And this can be tricky sometimes to understand. So my advice is always to benchmark and measure execution time of functions in order to be sure that you are optimizing the right piece of code. Why things can be tricky on AWS? Because it's incredibly scattered, the information that explains input-output performances. So you need to really read around and try to understand the whole picture in order to make the proper decision. It's important because mistakes cost money. So, for example, you could have paying a lot for some fancy GPU instance, but with the GPU not doing nothing because it's starving. It can't. It's not fed with data fast enough. Because if you don't pay attention to all the caveats of the AWS infrastructure, you pay for something that you don't use. So, first overview of the possibilities that you have to store data on AWS. There are basically 4 things that you can use. S3 buckets that are basically huge network connected devices with extremely cheap, and they are limited by the bandwidth of your instance, so they are kind of slow. And you will never find information about input-output operations per second. At least to the best of my knowledge, I wasn't able to find how do they perform. Then you have the standard EBS volumes that comes with each instance that you can use. And again, they are limited both in throughput and EOPS. And they are free because by default you will have some attached. Then you have some fancy volumes called provisioned volumes that give you some guarantee of throughput and EOPS operations. They are quite expensive, and this is the tricky part. You could pay for a volume that should provide fast performances in reading and writing, but it will still be limited by the instance because each instance comes with some limitations regarding those two metrics. And last, the faster solution that you can have is using SSD storage that is attached to the instance, and then it's not limited by the instance itself, and the limitations are just hardware limitation. So we will focus on this 4 point. So as we can see, you can check for each kind of instance, there are hundreds of them, what are the throughputs that you can expect for the instance itself and the EOPS. And so depending on your needs, you can choose appropriately what do you need. Now, how to benchmark? There is this very nice library, FIO, that basically does a fast stress test of your volume, and you can check how fast it is. The second friend that you can use is net data, where you can check your system performances while doing the tests. Why it is a useful FIO? Because here, for example, with a simple line of code, you can check how fast you are reading from the disk, and it's very nice because as we can see, this is the same command repeated 2 times. In one time, the first time we are getting some performances, that is 500 megabytes per second of throughput and 33,000 EOPS. And the second time, all of a sudden, our disk is extremely fast, like it's almost 20 gigabytes per second and 1 million EOPS. So what is happening? What is happening is that the second test actually is not reading from disk, but is reading from RAM, because the results have been cached. So the files that are read all the time are not read from the disk, but they are cached by the operating system in RAM, and then you're reading from RAM. And this can be activated and deactivated using this flag direct. Why then is useful to use a FIO? Because this caching mechanism can be an issue if you try to measure things using your own code. And I think you really need to pay attention when you do that. Otherwise, you will get some results that doesn't make sense. So for example, here we have a function that reads some NumPy arrays from the disk. The first time that I call it, I need 3.44 seconds. Then the same function, nothing changed, the disk is the same. It needs almost four times less time. So it's not that all of a sudden my system becomes 4 times faster. It's just that the first read is a genuine read from disk, while the second one is a read from RAM. Because of that, pay attention when you benchmark. Otherwise, you could take the wrong decision when implementing your code. How can you check if you are reading cached data or data from disk? I have found this solution that I think, it's quite simple. Checking the CPU usage, you can identify IO wait time, that is here is shown in violet in the net data application. And this IO wait time tells you how much time your system is waiting in reading or writing. So if this is high, it means that you're really reading from disk. Otherwise, you are reading cached data from RAM. So going to the use case, we want to train a deep learning model using PyTorch. And basically, in order to feed data to the GPU, you use a data loader and a dataset. A dataset is simply a class that implements a method, get item. And every time that our GPU wants an item, the data loader asks to the dataset, and the dataset provides it. Of course, this item can be already in RAM or can be read from disk. And because of that, if our dataset is big enough it's bigger than RAM, we need to have a get item method that reads directly from the disk. Of course, when you train, usually what you do is that you need to do a lot of parallel readings operations. So this is quite stressful on the infrastructure, on the volumes that you're using. And this is why it's easy that the disk and the kind of disk that you're using is the real bottleneck of your training. So since using GPUs is expensive, you want to maximize the GPU usage. That is, you want that it's 100% used all the time. In order to do so, then, if you have to read from disk, you can see from the AWS pages that each GPU instance comes with attached a given amount of storage, and this is this fast SSD disk that we were talking before. And based on that, you can choose, the size that you need. Paying attention that not all the GPU instances has this storage. So, in this case, I spent a lot of time because noticing that using the wrong kind of instance that were reading from the volume that is not fast SSD. And because of that, I was losing time. So again, how can you check if you are maximizing your GPU? Again, with net data, you can see that at training time, for each epoch, your GPU is nicely at 100% utilization. And this means that the reading operations are not the bottleneck. So thank you for your time, and I hope that it was interesting for somebody.
Thank you, Domagoj. Yeah, great talk. I think we learned something new. Does anyone have any questions?
Yeah.
You would have to know if you have a question or because Rur is looking like he wants to speak. No. Okay, go ahead, Rur.
Domagoj, can you get data like from S3 or any kind of network directly onto the GPU, or do you have to go like through the SSD?
No, you can, but the point is that for this specific, there are specific parallel file systems that I didn't check in this context that are used for big data applications. For example, this Lustre file system that is really optimized for heavy operations like those. But for this specific case where you need to read thousands of small files, I think that nothing that is network connected has a latency that provides you this.
Cool,
But you can, in principle.